Temporary hard water. Hard water that contains calcium hydrogen carbonate, CaHCO3 and the same magnesium, but with magnesium hydrogen carbonate, is temporarily hard. These minerals are dissolved in the water but are able to be precipitated out by boiling it or adding lime, which is calcium hydroxide. The source of these minerals is usually from geological formations such as limestone or chalk. When the hard water is boiled, dissolved minerals of calcium carbonate and magnesium carbonate can precipitate out of the water. Water that is not hard is called soft. Treating hard water to make it soft water is called softening. The chemical reactions below show this boiling and precipitation. So through this boiling process, we boil this aqueous calcium or magnesium HCO3 and we form carbon dioxide gas, water, and then we precipitate out the solids of calcium carbonate and magnesium carbonate. In these reactions, AQ means dissolved in water, G means gas, L means liquid, and S means solid. Adding lime to temporary hard water will also cause dissolved minerals to precipitate out. The chemical reactions below show this chemical reaction forming a precipitate. So if I add lime, I'm also going to precipitate out calcium carbonate here, magnesium carbonate, and calcium carbonate here from the addition of the lime. Permanently hard water. Unlike temporary hard water, permanently hard water cannot be softened by boiling. Permanently hard water has concentrations of calcium sulfate and magnesium sulfate. These minerals end up in water that has passed through aquifers. The calcium sulfate comes from gypsum deposits, which are soft, white minerals containing calcium sulfate. The magnesium sulfate comes from salt deposits underground. Softening permanently hard water. In order to soften permanently hard water, the calcium and magnesium ions have to be removed through various chemical reactions. We can't just boil. Some complex methods of doing this include the following. 1. A Calgon process. This uses the addition of sodium hexametaphosphate, shown here, also known as the Calgon salt. This salt ionizes to form Na4P6O18 with a 2- charge. This ion interacts with calcium or magnesium ions, and some sodium ions are displaced from the Calgon anion to capture the calcium or magnesium. As you can see here, a couple of the sodium ions are displaced and replaced by a calcium and a magnesium in this process. Another way to soften permanently hard water is by using ion exchange resins. This process involves large organic molecules with acidic groups that give up an H+ or an OH- ion to capture the calcium or magnesium ions. So you can see our acid resin here that has ion that it can give up, and in doing so, the calcium can be captured. Resins with basic groups can be used in a similar way to remove anions, such as HCO3- from the water. So if we have anions in the water rather than metal cations, we can also use anions in this process. Measuring water hardness. When soap scum and mineral deposits can be observed, water is very hard. The table below summarizes the degrees of water hardness by concentration of grains of minerals per unit of water. So if we have less than 17.1 milligrams per liter or parts per million of grains of minerals per unit of water, we would call that soft water. And we go up our scale here till we get to over 180 parts per million, and that would be very hard water. Various tests can be used to measure water hardness. The simplest test that can be done at home is the suds test. Add 10 drops of dish soap, not detergent, to a 350 milliliter glass of water. Shake it and look for suds. If there are suds, then your water is soft. If there are no suds, add another 10 drops of soap and repeat the process. The chart below is a crude guide to measuring the hardness of your water sample based on the number of drops of soap you had to add to the water to observe suds in it. If no suds are observed, the water is very hard. If we start with 10 drops of soap and we observe suds, we'd call that soft. As we add 10 more and 10 more and 10 more, and that's when we see suds, we go from slightly hard to hard. And then if we add 50 drops of soap and we still don't observe any suds, we would classify that as very hard water. Other tests to measure water hardness can be done with chemical test strips or electronic test meters. Chemical test strips have chemicals that react with the minerals in the water and form a color on the strip that can be matched on a color indicator chart that specifies the hardness, as you see here. The primary chemicals used are calmagite and EDTA. EDTA binds the metal calcium and magnesium ions in the water, and the calmagite will change color once the metal ions are bound. Electrical test meters, such as total dissolved solids TDS meters, measure the electrical conductivity of the water. The higher the conductivity, the more metal ions are in the water, and the harder the water is.